Welcome to Triangle Similarity Postulate podcast. So similar triangles are triangles that have the same shape but not necessarily the same size, right? And we know that they have to differ by a scale factor, and all our sides have to be in proportion. So for instance, here we have triangle ABC is similar to triangle DEF. So if those two triangles are similar, we know that there are several repercussions that come from it. So first of all, the corresponding angles have to be congruent. So angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F, and then the corresponding sides are going to be in the same proportion. So the ratio of AB to DE is going to be in the same proportion as BC to EF as to AC to DF, right? So those corresponding sides have to be in the same proportion, and I can also mark it up here, right? So AB is in the same proportion as DE. You can barely see that blue one there. And BC is in the same proportion as EF, and AC is in the same proportion as DF, right? So our corresponding sides have to be in the same proportion. Right, but we're going to learn a little bit more about similar triangles in this lesson, because triangles are a little bit special, just like they were when we had our congruence postulates. Triangles are just a little bit special. So similar triangles are like similar polygons. Their corresponding angles are congruent, and their corresponding sides are in proportion. So here we have two similar triangles. And so one way it's really easy to figure out the corresponding sides if you're not sure. Just match up small with small. All right, so that's 3 and 6 are the two smallest sides, which is 1/2. And medium with medium, so the two medium sides are 4 and 8, and they also reduce to 1/2, and then large with large. And the two largest sides are 5 and 10, and they also reduce to 1/2. So notice that all of our corresponding sides are in the exact same proportion. So therefore we know these two triangles are similar. But you don't need all that information to be able to tell that two triangles are similar. And our first one is angle, angle, and this one's in your notes. So angle, angle similarity postulate. If two angles of one triangle are equal to the corresponding to two corresponding angles of the other triangle, our two triangles must be similar. So for triangles only, if we have two angles are congruent between the two triangles, our triangles must be similar. Third angle theorem, remember, if two angles of one triangle are congruent to two angles of another triangle, the third angles are congruent as well. That is only true for triangles. So with triangles only, two angles is going to be enough that two triangles must be similar. So if you have two congruent angles, the triangles must be similar, right? That it only works for triangles. Triangles are the only polygons that have some congruence shortcuts and similarity shortcuts. All the other polygons, you have to show that all the corresponding sides are congruent, all the corresponding angles are congruent for congruence, or all the corresponding sides are in proportion and all the corresponding angles are congruent for similarity. Not so for triangles. All right, so here triangle KLM is similar to triangle HIJ using angle, angle, triangle similarity postulate. Okay. So the proof here of our angle, angle similarity criteria. And I was just checking to see if this one's in the notes. This one is in your notes. It is on the back of the notes, probably because it didn't fit anywhere else. So I figured I should tell you that because you might not see it otherwise. So the last page of your notes, we have this in your notes, and you can fill this along with me. So we're given angle A is congruent to angle X, and angle B is congruent to angle Y. We want to prove that triangle ABC is similar to triangle XYZ. So to prove that the triangles are similar, we need to find a sequence of similarity transformations that maps triangle ABC to triangle XYZ. All right, so to review, a similarity transformation is a dilation on its own and or I should say a dilation and possibly a congruence transformation. We can have just a dilation, but we can also have a dilation with a congruence transformation. And a congruence transformation, of course, is a translation, a reflection, or a rotation. Those are transformations that don't change the size of an object. All right, so we want to apply a dilation to triangle ABC with scale factor with scale factor K equals XYAB. I'm just trying to move this just a little bit. There we go. And we want to let the image of triangle ABC be triangle A prime, B prime, C prime. All right, so all we've done is we've dilated triangle ABC. So triangle A prime, B prime, C prime is similar to triangle ABC. And angle A is congruent to, angle A prime is congruent to angle A. And angle B prime is congruent to angle B because dilations preserve angle measures. Right? Our angle measures, that's one of the defining features. Oops, missing a U in there. One of the defining features of a dilation is that it preserves the angle measures. Also, A prime, B prime is K times AB, which is equal to, all right? So now if all I do is I'm translating, this is just a translation here. We know that for a translation that the corresponding sides are going to be congruent to one another. So we had a dilation, and then we have a translation here. So K times AB is going to be equal to XY divided by AB. Right? We have that right up here. Okay? So the scale factor here is always going to be our image divided by pre-image. Okay? So since all we've done is translated A prime, B prime, C prime to get X, Y, Z, and A prime, B prime, C prime is a dilation of A, B, C, right? Those sides have to be in the same proportion. I'm going to continue. I need another page. It is given that that angle A is congruent to angle X, and angle B is congruent to angle Y. Right? So we were already told in the beginning that those angles were congruent. Right? We know the angles are congruent when we dilated, because dilations preserve angle measures, and we were already told that the angles were congruent, angle A and angle B and angle X and angle Y to start this proof. By the transitive property of congruence, since angle A is congruent to angle X, angle A prime is congruent to angle X, and angle B prime is congruent to angle Y. So triangle A prime, B prime, C prime is congruent to triangle XYZ by, well, let's go take a look at what we know. All right, so this, actually let me add one more thing over here. So xy over AB is the same thing, right, as A prime, B prime over AB, right? Because that one was just a dilation. So we know that these sides here are congruent, and now we know the angles are congruent, right? So we've got angle, a side between, and angle. So this would be angle, side, angle, triangle, congruence postulate. So this means that there's a sequence of rigid motions that maps triangle A prime, B prime, C prime to X, Y, Z. And so a dilation followed by a sequence of rigid motions shows that there's a sequence of similarity transformations that maps triangle ABC to triangle XYZ. Therefore, triangle ABC is similar to triangle XYZ. And you can do this on a coordinate plane. So if we dilated a figure, okay, and we did some other transformation, we could go backwards and show that, well, when we dilated we had similar figures, and if we dilate and then we do some other transformation, we still have similar figures. And that's really all we showed here in this little proof. Right? Right, so we just used similarity transformations to show our triangles were similar. Let's look at the problem below here, and what would really help is a picture. So we should draw a diagram to go with it. In triangle JKL, the measure of angle J is 40 degrees, and the measure of angle K is 60 degrees. Well, let's draw a triangle. And it really doesn't matter what our triangle looks like. We just need a triangle. Right? And so JKL. And so J was 40 degrees, and I'm not worried if I drew this to scale, even close to scale. And K is 60 degrees. In triangle MNP, so now we just need another triangle, and I'm just going to draw another triangle. It doesn't really matter what it looks like. It's just a model. MNP. It's just here to help me organize the information. Angle M is 40 degrees, and angle P is 80 degrees. A student concludes that the triangles are not similar. Do you agree or disagree? Why? Well, the first thing we ought to do is find out what the other angle measures are. Okay? So step one, find the measure of angle L and the measure of angle N using triangle sum theorem. Right, so we have 40 plus 60 plus angle L is 180 degrees. That's 100. And if we subtract 100 from both sides, angle L is 80 degrees. And over here, we have 40 plus 80 plus angle N is 180 degrees. All right, so that's 120 plus angle N is 180 degrees, which means angle N, if I can squeeze it in here, is 60 degrees. So notice we have three congruent angles. We just had to make sure we found the measure of the other one. So just because the two we had didn't match, once we found all three angles, we see that our triangles indeed are similar. So do we disagree or disagree? We disagree. Since angle J is congruent to angle M, and angle K is congruent to, actually, let me do the ones we'll use that one first. And angle K is congruent to angle N, and angle L is congruent to angle P. Triangle JKL is similar to triangle MNP using angle, angle, triangle, similarity, postulate. Right? So don't assume that they're not similar until you find out the missing information. Okay? So the two triangles were indeed similar. Okay, so we want to determine whether or not the triangles are similar. Actually, I'm going to leave this for a question for you. So I don't think this one is in the notes. Nope. So I'm going to leave this one for you. And then we'll see if you got it right. All right, so we want to show that our two triangles are similar. All right, so this one is on, because it didn't fit in, is on the second page. And we're still looking at angle-angle similarity. And you know what? Actually, I changed my mind. I'm going to do this one because it's already up here on the board. So I think I will do this problem because I don't want to split this concept up into two podcasts. I want to at least cover our first triangle similarity postulate in one podcast, and then I'll do another podcast for the others. So let's do this problem, and I'll save you a different problem. All right, so we want to determine whether the two triangles are similar. All right, so we need to find the missing angles. All right, so we have 55 plus 46 plus angle S is equal to 180. And that's going to give us 101 plus angle S is 180. And that means angle S is 79 degrees. Uh-oh. Well, this looks like it's a big old no, because I don't see a 79 there. I've got a 55, a 46, and a 79. And I've got an 82 there. There's no 82 over here. But let's just double check. All right, so 82 plus 55 plus angle X is 180. So that's going to give us 137. Plus angle X is 180, which means angle X is 43 degrees. Well, 43 and 79 are not the same. I don't even know if there's an answer here, just a box. There we go. So, no, the measure of angle S is 79 degrees. Measure of angle X is 43 degrees. Therefore, the triangles, and I'll just put their real names. Therefore, RST is not similar to triangle XYZ. And it doesn't matter how I list those angles because they're not similar. So we're not matching up anything. Right? So sometimes your triangles will be similar and sometimes they won't. Make sure you find the missing angles when you have a problem like this. All right, let's go on to this one that's in your notes. And we want to show our two triangles are similar. All right, and we're told, or that we can see, actually, if I move this little triangle off, you can actually see it. All right, so DE is parallel to segment AC. So we're bringing back our parallel lines, right? A lot of the concepts in geometry come back in, when we're solving other problems. So if you will take a look at those, right? We've got parallel lines, and I'm just going to extend these for a moment. And we have a transversal. Notice the position, the same side, they're both on the right side, and they're both above a parallel line, and they're both the same measure. Right? Even if we didn't have a measurement in there, we would know that they were the same measure because those are corresponding angles. And we know corresponding angles formed by parallel lines are always going to be congruent. All right, so now we want to figure out whether the two triangles, the little triangle, DBE, and the bigger triangle, ABC, are similar to one another. And you may find that helpful to draw them separately. It's a lot easier to work with triangles when they don't overlap. All right, so this is triangle DBE. All right, and now we want to figure out what we know in these two triangles. All right, well, we're given that angle A is 79 degrees. And we can see that angle D is also 79 degrees, so those angles have to be congruent. All right, so let's fill in the blanks. So because the measure of angle D and the measure of angle A both equal 79 degrees, angle A is congruent to angle D. By the blank, angle B is congruent to blank. Well, what possibly could angle B be congruent to? I see. I've got triangle ABC and triangle DBE. What do they have in common? Maybe it's this angle right here, right? Those triangles overlap, right? And they both have an angle B, and it's the same angle. So by the reflexive property, angle B is congruent to angle B. So triangle DBE is similar to triangle, so if I call it DBE, it has to be ABC. By the angle, triangle, similarity postulate. All right? So if two angles in one triangle are congruent, the triangles have to be similar because we know the third angles are going to be congruent as well. All right? So let's try another problem. Show that the two triangles are similar, triangle QSR and triangle UST. So angle 1 and angle 2 are blank angles, so they are congruent. Look where they're located. Opposite one another. Share a vertex. They are vertical angles. And we know vertical angles are always congruent. You can't see it too well here. I'm going to draw it in a little bit better. Oh, and by the way, I think this one is also in your notes, right next to the one we just did. All right, so here you can see we have two parallel lines. So QR and TU are parallel line segments. So the blank angles are congruent. All right, so if we take a look there, we've got parallel lines. I can pick either one of these transversals, but I'll pick this one because I already made it darker. And we have a transversal here. All right, so don't look at the other line that's going in between. Just focus on the green lines. And we have angles on opposite sides of the transversal between the two parallel lines. Those are alternate interior angles. I give myself a whole lot of space for the word alternate interior. Therefore, angle R, oh, I chose the other angle, RQS, and so I could have chosen the other angle too. Since I have RQS there and QRS is congruent to, oh, actually, that's okay. That's okay. We'll do this one first. So we'll just move to QRS because I have them both up there. So QRS is congruent to angle, right? Go the same direction, UTS, right? So just this angle here is congruent to that angle there. Maybe you can saw the spot I made. All right, so that's angle, what did I just say? UTR, excuse me, UTS. I have to end in my triangle. UTS. And if I extended this line, this is also a transversal, this one here. So we can either use the fact that these would also be alternate interior angles, or the fact that this is the third angle theorem. If two angles of a triangle congruent, so are the third angles. Angle RQS has to be congruent to angle TUS. So triangle QSR is similar to triangle UST by the angle triangle similarity postulate. Right? It's another angle. That's because it's the only one I've taught you. I can't possibly teach to have us do any other thing but angle right now. I think that might be my last angle one. Yes. So I'm going to stop this podcast. We've gone over angle, and in the next podcast we're going to learn another similarity postulate. All right? So I hope you found this helpful, and let me know if you had any questions. All right? Bye for now.